Welcome back, and we are about to start our second session of Location and Business Intelligence program. The previous session you had, had an insight on location-based marketing and advertising in the new normal, mobility data generation in retail and real estate insights. So this session will be divided into two sections, basically. One, there'll be a lead talk by speaker from Oracle and Literati, and then we will have a kind of session which will be talking about efficient logistics and supply chain operations in the real-time, location intelligence perspective. May I invite our first speaker of the session, Mr. Shintaro Nagaoka, Principal Product Sales Consultant, Oracle.
Thank you very much for attending this session. As announced, that I have a little more generic approach to this session, but I try to make it that the overlap maximum. So actually, there are actually two elements in my story which keeps coming back. One is actually trying to use the data reusable for multiple purposes. That's one. Somebody who's been sitting in the morning session, they already heard me asking this question already. So this is something which we think is important. Another thing is actually through data enrichment, how can you increase the value of the data and the insight you get? These are two things, and I'm trying to combine it into one story. So in general, this is really something nobody should argue, I think. You try to aggregate data, putting more context to the existing data set so that you have more value to the existing system. So if you say, yes, you have a logistics systems and you have the data, then you may want to know what are the times that your logistic customers are likely not at home. If you have that kind of information, you may increase the service level of your solution, right? So by aggregating more data sources, can actually add the context and then also the value of the solution. And I think that one of the reasons why the relational database has been popular all these years is because relational database does this. This is what I do not want to recommend through my presentation for a number of reasons. The spreadsheet.
So we have audience on later, so if you would just...
Oh, right, I should be moving. All right, sorry. So I should stay here? Right. Okay, thank you. So the spreadsheet has a couple of problems, actually. Next to things like data securities and availability, usually data is static. So if the data source is changing constantly, you don't have up-to-date data in the spreadsheet. But spreadsheet is a kind of some symbolic thing, because I know a lot of customers who are not using spreadsheet, but their environment looks like a spreadsheet. And there's another problem with this approach. You're carrying all this data, maybe not for all the reasons. So you may want some of the columns, but you have all the time with you. And the third one, which is maybe the biggest, is some of the data you're carrying in the spreadsheet may be very useful for the other purposes. But how can get ever use that part of data of your spreadsheet for the other new applications? These are the kind of problems. That's why I am saying this is not recommended. So the requirement for the environment I would recommend is about the data management platform, which is fully aware of what kind of data it's receiving. Why is that important? If you have let's say, a lob column, and you put in data just like that, or something, some people do with the big data, then there is no understanding of what data is stored until application comes in. So if you want to reuse that data, for the second application or third, you need a part of the application logics for the second or third application. So you rather want that kind of logic, which is repeatedly needed, into the storage. This is actually my statement here. So if you want to store JSON files, if you want to store the XML files, or relational or locational based, geospatial, ideally, if data management is capable of understanding what it is, then things get much easier and flexible. Second, I'm talking about the data aggregation. So the platform should be able to facilitate this data aggregation process. Ideally, it's using SQL because it's kind of mostly common language we know. We also been seeing that in big data, increasing number of SQL-related technologies are coming in because in the beginning, people were not doing very much SQL, and gradually, a lot of the SQL-related technologies are coming into big data, or data lakes, as you want to call. So this is something I think is quite so obvious. So if you want the data logics to be stored next to the data, you must have some kind of facilities, like functions and operators, so that you can ease up the aggregation process. I hope I'm making sense and that I'm making clear. And in case of this kind of aggregation, all the temporary storage objects are stored inside that part. Because if you don't take this approach, excuse me, you might end up in this occasion. So you have a kind of a stovepipes, some people call it data lakes, and they're integrated in a kind of custom manner. But this makes a reusable setup almost impossible because every integration has its own way, and maybe with the upgrade of some of the components, you have already some challenge. So this is something we do not want to recommend. And what about things like the data securities, availabilities, and that kind of things? So there's a thing which Oracle has for so many years, but Oracle just came up about 2 or 3 years ago with this term. And once again, it's something which all exists for a long time. And they call it Converged database. And Converged database is about Oracle database being capable of dealing with practically any data types. So Geospatial, XML, text, JSON. Actually, there's even a logo of the blockchain. There's a thing called blockchain table, which actually has the behavior of a blockchain, but it's a table, so you cannot delete it. You cannot delete any records. It's also all the transactions that are coupled with the cryptographic operations, so we know who did change anything. And these kind of things that are there. So you have a freedom to store any kind of data, but to process it in a way you like. And if you like the same data for another application, another process, you're fully free to do so. And if you take it closely, look, there's even thing called the machine learning. And the machine learning is inside database kind of analytical capabilities. You can look for the patterns, you can look for anomalies, and by defining some kind of the patterns, you can do the predictions and that kind of things. They're all in the database, so you don't have to leave the data out of the database. So what does it mean to you? And this is actually one of the key points to me, mate, is actually if you have an application A, which is taking, if I look at closely, it looks like it's taking some of the relational data and maybe some of the document data. I don't know exactly what I meant by this. But this application A is retrieving data from two data types in this case. But you can equally do other applications, but some of the data are used again for another purpose. And you can keep doing this for forever. So the meaning that data you are storing in the database, in this case, can be used for countless number of the applications. So you don't have to store for every single application a kind of copy of the data, which is obviously the case in case of a spreadsheet type of application building, right? So in case of this, and if you agree with this, all the joins, and these are the really joins, and I'm going to show you the example in a minute, they are SQL-based. So you select columns and from some tables containing geographical data, some table containing JSON data. And that goes on forever and ever. And to make that things possible, Oracle introduced a number of things called functions, operators. And you're going to see some examples in a minute. So, and what does it also mean, based on this slide? Application, the real application that the users are facing with, they can be written in Python, C++, .NET, Java, Python, whatever. Because all this database logic is agnostic to the programming language. So you don't have to know some language specifically to do this, because you do these data logic things inside the database, and later you can decide in what your favorite programming language you can build the application. So they're separated. Okay? So there's another effect here. So yeah, this is the example I was talking about. This is one select statement, and you don't really have to try to understand everything. But it's a one select statement which is asking for a number of the locations within the distance of 35 kilometers from some certain point. It's asking for some of the relational output and some of the non-relational output. And it's in this example, there are two operators used. One is more Oracle text operator. Oracle text is capability to store any kind of documents like a PDF, Words, all kinds of things in a database, index it, and you can do all the retrievals. By the way, you don't have to store everything in the database. You can also keep it outside. And geospatial data, it's in an Oracle database in this case again. And for that, Oracle provides a lot of functions. One of them is here. And it's called SDA within distance. So you don't have to develop that operator yourself. It's been tested. It's been further developed. And Oracle provides hundreds of these operators and functions and procedures. So they're all in the database. So you don't really get to know them until you use it. But since they are in the database, you can program these kind of logics inside the database without bringing the data outside. So you can keep it safe, you can keep it scalable, you can keep it high available, all kinds of things. And what kind of the areas of geospatial operations does Oracle support? Well, some of the things on the screen. So it's not only geometry about points, lines, and surfaces, 3D object, so things like the point cloud, the thing like the topologies, linear referencing systems. That's maybe close to your industry because it's about the route. This route, and if there's some kind of a trouble with one route, what are the alternative routes to reach the same destination? These are all built-in functions, right? So, and also things like a raster and the 3D, so think from the aerial pictures, you can analyze things, all these are there. So these are built into functions, so you just have to invoke them. You have to know their existence and you invoke them. Oracle has been traditionally working closely with many, many partners, and some of them are downstairs at the exhibition hall. And so Oracle does not really have a tendency to say, you should be using with that application. It's your freedom to what to do with your data. Oracle does provide also the front ends, which have not commercial value, so they're all free for use. And some of them are more spatial related, and some of them are more analytical, generic analytical related products. And since you have all the logics in the database, you can easily build your own application, which I call low code, because all you have to do in the application is more user interface, some of the other things, but all the database logics are inside, so you can build these applications easily. And one of the things here is in the next slide, Oracle Spatial Studio. Oracle has an intention to make the geospatial technologies more available to people who are not really specialized in this area. So by having the more business background, this tool will make the people easier to access the spatial data combined with any other data, and to make it visible and do some analysis. And this is actually something that Oracle's been pushing a lot. So summarizing, I state that geospatial data can add essential context to a data set, which must be very obvious for this audience. Every data enrichment can add more value, more context to the existing data set, which must be also very obvious to this audience, I think. And if you use the appropriate technologies, which enables this way of working, then you can really keep adding the combination of the same set of geographical data, which is kind of exaggeration because it can be different geospatial data. But even with one set of geospatial data, you can have a countless number of combinations according to your need. So it's really about reuse. And that Oracle database is one of such environments which enables this way of work. And then, yeah, if you don't have a redundant data storage, you don't have the issue with the data quality, conflicting data, and also the ownership costs will go down. So this is my conclusion. Thank you very much for your time.
Thank you, Mr. Shintaro. Is there any questions for the speaker from the audience? Anybody would like to ask, clarify, present something, their views?
Complaints?
Yes, complaints or anything? Yes.
I'm new to the industry, so it's probably really, really stupid. In terms of your front ends that you showed there, the data that goes into them, have Oracle got any predefined connections with people that do things like, for example, we do travel time. Do Oracle connect directly to external sources to offer their customers that off the shelf almost?
Yes, it does. But actually, in reality, let's say you have some kind of a GPS-like devices on your vehicle, which is doing delivery. Then GPS has some kind of interface which makes their data available to platforms like a database. So if you have that infrastructure, yes, we can accept connecting. Yeah. Actually, I don't know where you're from. You from sound like a Nordic person.
Travel time from the UK.
All right, okay. But there are cases like in the buses, at the location of the buses and that kind of thing that exist for over 20 years. Actually. So these are being done already. And so the thing like one other cases, which is a little different from your case, but in San Francisco, and this is also existing for a number of years, you'll be driving in street of San Francisco, you're looking for the space to park. Then your location is known, and the spaces are also known through the cameras and all kinds of things. So they can give you where you can go to park your car. Thank you.
Thank you. Thank you, Dr.
So when it comes to business intelligence companies building location analytics or spatial analytics capabilities, how do you think that is happening right now? Is that through more partnerships with the location analytics giants, or RBI companies doing that in-house?
Well, it's a kind of a difficult question. It's also maybe politically difficult question to answer, but let me give it a try. I think some of the tools, once again, we're really agnostic to tons of those partner organizations. And since the Oracle technology is compliant to the OGC standard, we can probably talk to everybody, right? So it's kind of up to the other party how the data is dealt with, actually. So some of the solutions take all the data from Oracle database and do the local analysis, which is fine, but it is not the only way. You can do also a lot of things inside the database. So you can do the network traffic you can bring it to the minimum, actually. Yeah. So you have a broad spectrum of how your solution can be built. Does that make sense? Yeah.
Thank you, Mr. Shintaro, for
Welcome.
this wonderful presentation. Thank you
Okay.
so much.